Hi guys, welcome back to the limit section. Today we're going to talk about finding limits using factoring. So in the last couple of videos we looked at this function x squared minus 1 over x minus 1. We said f of x is equal to this, and what we wanted to do, we wanted to find the limit as x goes to 1 of f of x, right? And we did this a couple of different ways. We graphed the function and we saw that it goes towards some value, right? Like as you approach 1, uh, f of x approaches some value, but we didn't like that method much because you can't always use that, right? If the function is very complicated, you might not be able to use it, and you just aren't 100% sure, right? And then we also looked at using a tabular method, like an analytic method. Just write down numbers closer and closer to 1 from either direction and see. Today we're going to use a much more exact method though, right? So the first thing we can do, we're going to remember factoring is what we're doing. So we can, that already gives you a clue about what to do. Notice that x squared minus 1, this is just a difference of squares, right? So this is a difference of squares. So we can write this as x minus 1 times x plus 1. So this is our numerator and we're dividing it by x minus 1. And so f of x is equal to this, right? Now, because we want to take the limit as x goes to 1, we don't care if it's defined there or not, right? We just want to see what it would go to if it were defined there. Okay, this is an equivalent way of writing the function. F of x equals x plus 1, where x is not equal to 1. But we don't care whether x is equal to 1 or not, whether that's allowed or not, because we just want the limit. So now we can plug this in. So we'll write limit as x goes to 1 of f of x is equal to the limit, again as x goes to 1 of x plus 1, and this you can just plug in the x over here. This will give you 2. So that's the same answer that we got. And if you're confused about why we did this, like why we cancel these out, it's because the function doesn't need to be defined to have a limit. Remember, we don't need the function to be defined at a point to find the limit at that point, and that's why we ignored this criteria, this criterion over here. Let's move on to a slightly harder example. What about x to the third power? So x cubed plus 1 over x plus 1, and we want to find the limit here as x goes to negative 1. Again, if you directly plug it in, you'll get 0 over 0. But we can write this out again as the numerator can be written as a product. So we write it as x plus 1 times x squared minus x plus 1. So this is a fairly common expansion. You've probably seen this before. And then over here, we'll just write again x plus 1. Right now, we can cancel this with this. So this becomes the same thing as the limit as x goes to negative 1. That's all. That's not going to change ever. That's just the same thing. And now we've got x squared minus x plus 1. Over here, we can just plug it in, right? This is negative 1 squared minus negative 1 plus 1. So this becomes 1 plus 1 plus 1, which is equal to 3. So there you have it. That's our answer for this question. And that's basically how almost any factoring problem will be done. Sometimes you might have to factor more than once. Maybe maybe you have to take out a few different factors, but it's almost always the same idea. With that, let's take a look at a few more properties. I didn't want to do all the properties in the last video because that would make the video too long, and I didn't want to overburden you there. But basically, there are two more important properties. This one is pretty easy. The limit as x approaches a of c times f of x, okay, that's a c, is equal to c times the limit as x goes to a of f of x. And that's like probably pretty straightforward. You basically can just take out a constant. If there's a constant, you can take it out. And another one, now this is a very powerful one, okay? The limit, one second, the limit, again as x goes to a, of f of x to some power r over s. This is equal to the limit as x approaches a of f of x. And you can raise the whole thing to the r over s power. Now, keep in mind r, like if s is 1 and r is an integer, that's basically any exponent. But if s is, if this r over s becomes a fraction, then you can also have like square roots, cube roots, and that sort of stuff. So this can make your work pretty easy, especially as we deal with harder and harder questions. So thanks so much for watching this far, guys. That's all there is for this video. We discussed how to find limits using the factoring method, which is a lot more precise of a method than the graphing and tabular or numeric methods. In the next video, we're going to look at rationalizing, which is another very important method to use. And I'll see you in the next video. Bye.